In this brief video, we will see how to solve a typical factoring problem from a GED practice test by using guess and check applied to the given answers as well as multiplication, thereby avoiding the whole issue of having to factor the original given problem. On the screen, we can see a sample GED problem where we are asked to factor the algebraic expression 3 times x squared plus 7 times x minus 6. Now, rather than actually using algebraic techniques of factoring, I believe it would be easier for us to, as I usually do, make use of the answers that we are already given and see if we can work our way backwards. In other words, given A, B, C, and D, and some products that are shown for those, can we show that one of those products is the same as the original problem we were given, thereby bypassing the whole need to factor? So let's see how that would work. I'm going to use this graphical method of showing the multiplication. So I'm going to try answer A first. Let's try that one to see whether x minus 6 times 3x plus 1 is equal to our original expression that we were asked to factor. So I can put the x along the top. Notice I'm separating out the subtraction by attaching the subtraction symbol to the 6 as though it was a negative sign. And then I'm drawing a grid for keeping track of the work that I'm going to do in multiplying x minus 6 times 3x plus 1. And I'm going to put the 3 times x plus 1. Again, I'm separating the plus sign to attach it to the 1. And now you can see I've formed something that looks a little bit like an Excel table. If you ever have used Excel, then you probably understand what I'm about to do next. To multiply 3x plus 1 times x minus 6, using this table to keep my work organized, I'm going to apply the distributive property, which means I'm going to take each term from one of the binomials, each of these is a binomial, and multiply by each piece of the other binomial. So 3x times x is going to go in this particular box here. Notice I'm going across in the row and vertically in the column, and where they intersect is where I'm going to have my subproduct. And 3x times x is 3 times x squared. The exponent designates the fact that I have two x's that are being multiplied together. The next square over, the next part of the grid, is going to be 3x going horizontally times negative 6. And I'm going to put the negative 6 in parentheses so we don't get confused about the negative sign. And the multiplication here is just 3 times negative 6, so I'm going to get a negative 18, and then we still have the x being multiplied there. Now I work my way down to the second row and the first column. 1 times x is, of course, just x. And a positive 1 times a negative 6, I'll actually show that multiplication here, is going to equal a negative 6. Now I have all the subproducts in each of the 4 cells of this table. And all I need to do now to get the expression that they represent is to add all the pieces together. So the first piece is the 3x squared. Then I have a minus 18x. And I'm leaving off the dots in between, which I was putting to show multiplication clearly. Then plus an x, and then subtract 6. Now I can combine like terms, the negative 18x and the positive x combined together to give me 3x squared minus 17x minus 6. Now at this point I can see that this expression does not match the original problem expression. So therefore, this is not the answer. A is not the correct answer. And so now I would go about seeing if I could try something different. Now, I could go through all 4 of them fairly quickly using this method to multiply and find out which one is actually the correct one. But I'm going to go ahead and kind of cut to the chase just a little bit here and pick the one that I have a feeling is the correct answer. So I'm going to try now C, and I'm going to do that down below here. I'm going to use the same method. I'm going to go a little bit more rapidly now that I've shown you the individual steps. So we're going to have x plus 3. That's going to go along the top of the table, and I form the rest of the table as we did before. And again, I'm going to go a little more rapidly. So now I have 3x minus 2 3x times x is 3x squared. 3x times 3 would be 3 times 3 is 9. The x stays as is. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Again, I bring the terms all down below, and I do that here. 3x squared plus 9x minus 2x minus 6. I now combine the like terms in the middle. 9x's minus 2x's is going to give me a positive 7x. Bring everything else down. And I can see that my expression, 3x squared plus 7x minus 6, is equivalent to the original expression we were given. So therefore, the correct answer in this case for factoring is C.